Hello everyone, and welcome back to Aaron and Holmes Explain the Universe.
Today we're animated.
Yes, animated. In this episode we'll be discussing all there is to know about black holes.
So Holmes, what is a black hole?
A black hole is a region in space-time that is so dense that nothing can escape its gravitational pull, not even electromagnetic radiation.
Spooky.
Yes, black holes can be rather frightening.
Oh, not that. I think it's spooky that I didn't understand a word what you just said.
Alright. This is a black hole.
Ooh!
This black hole was created through the death and collapse of a star. The star's mass was so dense that it created what you see before you. But you see, Aaron, anything can become a black hole.
What? How?
Because everything has a Schwarzschild radius, of course.
And that is...
A Schwarzschild's radius is the radius an object would need to be compressed to in order to be dense enough to become a black hole. For an example, if the Earth was compressed in something the size of, say, a peanut, it would have enough mass to become a black hole.
Oh, wow. Okay, another question. What happens to objects when they go around a black hole but don't get close enough to fall in?
That's an excellent question. When an object, let's just say a star for instance, passes behind or around a black hole but doesn't fall in, the light from the star is distorted and changed because of the black hole's gravitational field.
And what does that mean?
This shows how the light from the galaxy passing by is not viciously sucked into the hole, but rather simply displaced and distorted. This is because black holes have such a large impact in their gravitational fields that they completely change the appearance of light objects. A more simple example to help you understand is the impact of the sun's gravitational fields to nearby stars.
And what does that look like?
Okay, here's a picture of the gravitational waves effect on a star that sits behind the sun from the Earth's point of view versus where it actually sits.
Wow. What would happen if two black holes collide?
Good question. Believe it or not, it is possible for black holes to collide. Though, if this were to happen, it would be very violent. To begin, once they got too close to each other, they would be unable to escape the other's gravitational pull. Once they merged together, they would, as expected, create a bigger black hole. But the collision would create a large ripple in the gravitational waves.
What exactly are gravitational waves?
Good question, but let's try to do one complicated topic at a time.
Okay. Well, what does it look like inside a black hole?
As it stands, we have no idea what exactly is inside a black hole. This is because observers cannot see past the event horizon, because the light and material that is beyond that point cannot travel back to us.
Oh, well, what would happen if someone were to go inside a black hole?
From what we know thus far, starting from outside the event horizon, the viewer would be able to see a perfect circle of pure darkness ahead of them. Surrounding the circle, they'd be able to see the distorted light of distant stars, and further out, the more familiar stars. However, moving closer to the black hole's center, they'd begin to accelerate because of the black hole's gravitational pull. Their body would begin to be stretched apart because of the difference in pull. The part closer would experience a stronger pull compared to the part further away. This process is what scientists refer to as spaghettification. If the viewer is falling into a small black hole, the pressure is so strong that they'd be torn apart before they even passed the event horizon. However, if it was a supermassive black hole, their body would stay intact past the event horizon, but afterwards their body would be condensed into a singular point of infinite density. At this point, they'd become one with the black hole.
Oh man, I lost you once you mentioned biscotti.
Do you have any other questions?
Well, do black holes live forever or do they eventually starve and vanish like stars do?
Well, first of all, stars don't just vanish, they burn out. And matter can't just poof away. But you are on the right track. We used to believe that black holes couldn't be destroyed, but I've found that black holes actually slowly evaporate over time and return their energy back to the universe.
What? How? I thought nothing could escape.
The quantum theory predicts that tiny subparticles are created and destroyed and sometimes have the chance of escaping before they are destroyed. This creates the glow that is seen around the event horizon. This glow slowly decreases the mass of the black hole until it is completely gone. However, this cannot be seen happening due to the size of the black holes we are able to observe. However, if we could find a black hole the size of, say, a cruise ship, it would disappear in a flash of light in less than a second.
That's awesome. So, when do we get to go inside a black hole?
Why would you want to do that?
Science.